Okay, so are you happy that there are 3 ways in which a 3-dimensional line, or 2 3-dimensional lines can interact with each other? Okay, you can either have what we've already looked at. They can intersect. Okay, now if they intersect, remember, so imagine we have 2 lines, R1 and R2, okay, is equal to general form of a line, okay. If they intersect, we need to set these 2 things equal to each other, and then we need to find the scalar which works in both, okay. So imagine it's mu and lambda, so this one's in terms of mu, this one's in terms of lambda. We need to find mu and lambda. As long as that's consistent across all 3 directions, I, j and k direction, then we know they must intersect, and then we can use that to find the intersection point. But what else could we have? Okay, so imagine 3-dimensional lines, they could intersect. What else could we have? Perpendicular, but wouldn't they also intersect? Yeah, okay, so something different from intersecting. They could be parallel. In other words, they never touch, but they carry on in the same direction. Okay, now think about it. If 2 vectors are parallel, so there's 1 and then there's 2, okay, parallel. So in other words, they carry on in the same direction without touching, okay? What quality of my vector equation of a line do I need? Good, so the gradient needs to be the same. Now, what was the kind of analogy for gradient in here? T. Not T. It's that bit, isn't it? It's the direction vector. T is the scalar that moves the direction vector. Oh. Yeah? So remember, that's the direction vector. Sorry. That's all right. And that's the position vector. Okay? So if they are parallel, it means that the direction vectors should look like each other. Yeah? In other words, they move in the same direction. So direction vectors. Okay, because remember, the direction vector tells you which direction the line is moving in. So in order to be parallel, the direction vectors need to be the same. Now just remember, they may not be exactly the same, they just need to be scalar multiples of each other. So like one might be 1, 7, 4, and then the other one might be 2, 14, 8. Yeah? Because they're still the same direction vector, it's just one is twice as big as the other. Okay? So as long as they're scalar multiples of each other, we're good. Okay? What's the third option? So intersecting, they cross each other. Parallel, they go off in the same direction. What's the third option, bearing in mind we're talking about 3-dimensional lines now? Exactly, they never cross. Okay, they're skew, they completely miss each other. Imagine like they come across but they miss each other completely. So we call that skew. Now, as a general rule of thumb, how do you show, so we know how to show vectors are, or vector equation of a line, we know how to show that they are intersecting. We set them equal to each other and we find a lambda and a mu that is consistent for both. Okay? For parallel, we need to show that the direction vectors, in other words, this part here, is just scalar multiples of each other. As a general rule of thumb, if it's not intersecting, if it's not parallel, the only option left is skew. Okay? So actually, if it shows, so like for example in this question here, it says for each pair of lines, find whether they intersect, parallel, or skew, okay? Check if they intersect. Well, actually, no, this is probably the easiest one to check first, yeah? Easy to check if they're parallel, you just need to look at them. Look at the direction vectors, okay? So if they're not parallel, then check intersecting. If they're not intersecting, that must mean that they are skew. Is that okay? Yeah? So in other words, not parallel, or intersect. Okay? In other words, if you check intersecting and if you can't find a mu and lambda which works consistently across all 3 I, j and k directions, you know it must be skew. Is that okay? So as an example then, could you have a look at question 15 part 2? So could you read out R1 for me? 031. Yeah. Okay. And then could you read out R2 for me? 6, -2, -1. Okay. Mu. -2, 6. Okay. -2, 6 was it?
Yeah. Oh, that's right.
-4, 2, 6. Yeah. So that's right. Okay, good. So this is how I would do it. Okay, I need to check whether they're intersecting, whether they're parallel, or they're skew. Okay, now actually I've written in the right, slightly the wrong order here. First I need to check if they're parallel. Okay, have a look. Are the direction vectors, well, that's my direction vector of R1, that's the direction vector of R2. Are they scalar multiples of each other?
Yes.
Let's have a look. So 2 times by what gives me -2? Good. So 2 times -2 equals -4. Okay. Let's check. So -1 times something has to equal 2. What's that something got to be? Okay, -2. And let's check. It's looking good so far. -3 times by something has to equal 6. What's that something got to be? -2. So because there's a scalar which is the same across all 3 individual directions, that must mean that this is just a scalar multiple of this. Okay, which must mean that they must be parallel. So R1 and R2 are parallel. Okay. Now, obviously, if they weren't parallel, so for example, you look at question 1, you look at the direction vectors, they're not scalar multiples of each other, then you would check intersecting. Okay? If you couldn't find a lambda and a mu which works consistently, then you must note they are skew. Is that okay? Nice and easy?